So that's it. Let's jump into things. Very happy to be here today. We're going to be talking about Kubernetes-Native backup, the what, when, and why. As everyone knows, there's a lot of buzz around Kubernetes. People are deploying large production applications in here, but the world has changed enough than traditional data protection, traditional backup. So we're going to focus today not so much on what Kasten does as a company, but what you need to think about, what has shifted, what you need to be aware of in this new environment, and we'll take it from there. But before we jump into things, let me quickly introduce both Deepika and myself. I'll let Deepika go first. Deepika, you might be on mute. All right, hold on a second. Let's see.
Oh, hi, I'm back.
All right, there we go.
Sorry, Wi-Fi gods. Hi, everyone. I'm Deepika Dixit. I'm a member of technical staff here at Kasten. And before that, I was at Tintri, and I got my master's from Arizona State.
Thanks, Deepika. So I'm Niraj, Tolia. I'm the co-founder and CEO here at Kasten. I've been working on store systems for what seems like forever to me right now. Been working at both large companies and small companies on different forms of storage systems, different forms of data management. But also I worked on my PhD at Carnegie Mellon, where I worked on deduplication. The one other thing I will mention is in the chat, people are saying that they have issues hearing. Evidently, other people can hear me just fine. So sometimes in Zoom, check which speaker you might have picked, and hopefully that will clear things up for you. Yeah. So that's it. That's a little bit about us. So let's first talk about something that there's still this misconception about, where people look at Kubernetes and they ask the question, is it ready for stateful applications today? And something that we have run into is that this is, there's a half-life of Kubernetes and where it started and where it is today. When Kubernetes started, it was built mostly for stateless because it's an early project. It was the early successes that everyone saw on this platform were also on stateless applications. But as time has gone on, and especially over the last 18 months or so, we're seeing a tremendous growth of stateful applications. That is, think databases, NoSQL systems, message queues, etc., in this environment. And don't just take my word for it. Right? When we look at data across the board, we see that when you look at a report that Sysdig released last year, instead of the containers running in Kubernetes, 50% of the top 10 popular ones were all stateful. 57% of the Kubernetes clusters that Sysdig is monitoring turned out to have a concept called stateful sets, which essentially means they're running something stateful in there. And today, when you go look at new interfaces such as the container storage interface, pretty much every provider under the sun, in terms of being storage providers, have drivers available for that today. So when I checked roughly a month ago, there were over 70 CSI drivers that you could plug and provision storage for your applications into this environment. But that's not all, right? When we look at even more recent data, 451 Research in the Voice of the Enterprise released data just a month or two ago that stated that of the enterprises they measured results from, and there were hundreds of enterprises in this, people running containers, over half of them had over half of the applications being stateful. So you need to unpack that for a second, but essentially from the people that responded, over half of them said, look, we are stateful containers make up more than 50% of our application base. And when you dig into what those kinds of stateful applications or stateful containers tend to be, it really covers the span. It's not like Kubernetes is just a fit for one particular kind of stateful app. We see relational databases, NoSQL systems, message queues, data, batch streaming. We'll illustrate some of this with live customer examples in a little bit for now. So that said, let's look at, the next open question is, given all of the work that is happening for stateful apps in Kubernetes, does the old way, your VM-centric or server-centric ways of data management still work in this environment? And it is our firm belief that the old way doesn't work because enough has changed with this entirely new wave of infrastructure. And we're going to talk a little bit about what some of those differences are. We're going to illustrate those differences via examples, via demos, and then we'll take it from there. So the first thing that we've seen right off the bat is just how you deploy an application has changed. There's no longer a virtual machine to an application mapping. An application that is composed of multiple microservices could be spread across all nodes in your cluster. These things get dynamically rescheduled, for example, for better load sharing. They will scale up and down. With the advent of CI and CD pipelines, we're seeing constant redeployments in this environment. Some teams are deploying to production multiple times a day. And you have multi-tenancy in place. So just how you deploy, how these applications run, where they run has changed. That makes it sometimes hard for traditional products to keep up and say, hey, maybe I can protect a server or VM, maybe I can protect all the storage attached to a VM, but that really almost never translates into an application. So that's one thing to keep in mind. And really what that means, given the spread, is when you're looking at data management, Kubernetes backup in these environments, one needs to focus on the complete application. So if you look at my laser pointer on screen, it's not just focusing on the persistent volumes or your databases. It is about focusing on the complete application, whether you talk about things like networking, your registry information, service accounts, secrets, configuration. You need to capture all of this to really perform a true backup of your application, right? Because without the 90% of your application components that are Kubernetes resources, it doesn't really work. You also want to think about abstracting away infrastructure here, where once you've done a backup, the newer constructs are to even treat Kubernetes clusters as temporary or transient. The customers that repave their clusters every few weeks or so for security reasons, and they move applications along. There are people that will perform cluster upgrades by moving the applications across. So when you look at it from that perspective, we need to make sure that any data protection product we deploy, any backup product we deploy, gives you that portability that Kubernetes is known for, whether it be across clusters, regions, even cloud providers. And finally, what you see on the left, when you go look at it from the application state perspective, is performing coordinated operations, understanding what Kubernetes means. So some of you are probably well aware of. We do know that Kubernetes has a very rapid release schedule. So it releases pretty much every 3 months. And then it also will stop support for releases that are more than 2 releases behind the most recent release. So in a period of 9 months, your cluster or your software running on your cluster could be potentially out of date. And the other thing that happens with this is that your Kubernetes APIs change. So something that might have been valid 9, 12 months ago, the API is dramatically changed. So when you bring your application back up, say from a backup from a year ago, it might not ever restore successfully if you don't understand the Kubernetes constructs and perform the translation, what we call transformations, so that the old version of specs get translated into the new as you start bringing them up. So these are some of the things to keep in mind. The other great change, large change that we've seen is the rise of DevOps in this environment. This is great, so excited about this, wish we could have had this 10 years ago. But with the focus on applications, with a focus on the developers, with a focus on self-service, It has allowed companies, organizations, teams to move much faster than ever before. Developers are now figuring out how to ask for infrastructure as code, whether it be a load balancer, an ingress, a storage volume. So you're no longer filing tickets to say, hey, give me storage, give me networking access. You request it, and this gets provisioned within minutes, if not seconds. However, what this also means is that the admin's out of the loop. You're no longer provisioning storage for a user and then creating a backup policy for that application, but there is a greater chance of either missing backup completely, also greater accidental risk, because a misconfiguration can blow away all your data, and we know of cases where this has happened. We're also, application scale has dramatically changed. Right? And this is not just the monolith to microservices transition. That is definitely contributing to it. But there are a lot of other things in play. When you look at Kubernetes, we touched upon the Kubernetes resources from a little while ago. We see that explosion in components. We see applications that will scale up and down in response to load. And leave alone applications, we will see clusters that will scale up and down in response to load. We see the number of data services in use rapidly explode, and often within the context of the same application. Developers are now free to choose the data service they prefer that's best suited for the application versus the 2 or 3 that IDE might have traditionally provided. We also see multi-cluster use exploding. It's not uncommon for us to see people running 20, 30, 50 clusters when running in production. So there's a lot to unpack there. And to illustrate this concretely, let's go look at one of our customers, Soprasteria, a very large French ID firm. This is just one of the clusters that we're deployed on. And they're running OpenShift in AWS. They run both Ceph, in particular RookCeph and EBS. So moderate size cluster, 50 plus nodes, bunch of RAM, large number of applications, large number of volumes, multi-terabyte. And on average, these applications are complex, right? We've selected a subset of some of the resources we protect in the application. And on average, this works out to be over 100 components per application, right? And you can very quickly do the math when you have deep retention policies, how you need to figure out handling millions of objects in a multi-cluster or larger cluster scenario. The other thing that we need to keep an eye out on is it is not possible to individually service either all these application components, all these applications. In this particular environment, 2 ops people are supporting over 700 developers. And having a system like us definitely helps there, but the underlying point is that you need broad policies, you need self-service for the developers. You can't be synchronous in terms of communication with them. You can't request them to implement a backup policy, etc. But there must be the facilities available that you can have a generic catch-all policy to apply to them. You might have the requirement to be completely transparent to their work too. So those are some of the things to think about as you hit scale in these environments. The other thing that you also see is a lot of diversity. This one particular cluster had pretty much everything you can imagine under your sun. So from the code perspective, that everything from COBOL to Go and Java based applications running within containers. And name the data service, they had it. So everything from your traditional relational stuff, Postgres, MySQL, even Oracle in here. We saw MongoDB, Redis, etcd, apart from Kubernetes, etcd, Cassandra. We saw Kafka, we saw Zookeeper, we even saw Hive running in here, and a few other examples there too. So how do you deal with this complexity? Something you're going to have to think about as Kubernetes usage broadens in this environment for you. So when we look at, Soprasteria in the previous slide, the general customer base as a whole, and going back to the earlier question that I had on the old way versus the new way. Generally, the old way tends to be very infrastructure centric in place. given what you saw about scale, given what we touched upon on how Kubernetes applications behave, what they look like, right? We believe that the old way will scale poorly in these large environments. They'll leave data exposed, and for a number of reasons. Right? Sometimes people will say, hey, can I go look at my VM level backup solution and deploy it here? And that works great for your data. However, your RTOs tend to be very high. When we look at people's playbooks for recovery, they tend to be manual. Where in a sea of tens of thousands of volume snapshots, you figure out the collection that belong to your application. It's always more than one. And then you graph that within Kubernetes manually, bring the app stack up on that manually. And that tends to be more complicated than you would really like, error prone, and don't want to go down that path. Some other people will try to do custom Kubernetes scripting, external scripting for that. So Prestera, for example, tried AWS Lambda to go back up all their applications before they started using us. Works great on day one. You tailor to the application, works great when you have a few applications in place. However, it tends to be a lot more complex to maintain than expected. It reduces portability because generally these get tied into some infrastructure, and difficult to maintain from the code healthiness perspective, but also from a security perspective. Who has credentials to do what? How do you do self-service in this environment? That becomes a very interesting challenge if you want to push this at scale. And then finally, some people will say, hey, look, I have a storage system, overlay that on top of whatever storage you have, and let's do backups and migration using my storage system too. We just think that's the worst of all worlds, right? You don't get the fault isolation. If your storage system dies, your backups might not be available anymore. It's lowest common denominator. There's very high performance, cost, security, overhead to that. So it's generally the worst of all worlds. We don't recommend you do that at all. So hopefully that gives you a little bit of color on, just how some of the things have changed, right? How things contrast and what you need to think about as you move forward. So we're going to next switch into discussing how to tackle some of these problems. And before we even jump into that, let's look at just a very high level what customers generally do. Customers can be running on-prem, on bare metal in VMs, in a public cloud on VMs, in a public cloud using a managed service. And they've all picked Kubernetes on top of that. And really, when you pick a Kubernetes-native backup solution, it should be able to run in all these environments. Today, internally, even at a relatively small company like Kasten, we have switched our infrastructure across cloud providers 4 times at this point in time. And being able to migrate applications, being able to say, look, Kubernetes is a common substrate, has allowed us to do that very seamlessly, generally in a matter of a couple of days. And that's something to keep in mind. How do you make sure you don't lose that portability across environments? And then within these environments, you'll have different categories of applications. You might have applications that you've just done a lift and shift, and you have containerized that. You might have either net new applications, that is, you've designed them ground up to be microservice-based, what we call cloud-native applications, or applications that might have been refactored. Used to be a monolith, and then now turns into a cloud-native app. And we've seen successful examples of this, where what used to be a monolith has now turned into a few hundred different components, 30 plus microservices, and people can pull that off successfully. So this is just high-level overview of applications, Kubernetes, infrastructure. I'm going to hand it over to Deepika next, who will take you through the rest of the presentation. I'm obviously both here to also answer questions, both on chat as well as live. But I'll let Deepika take you through how we fit into this environment, walk you through demos of the system, and a few other things to keep in mind as you go down this path. All right. So Deepika, all yours.
Yes, thank you, Niraj. Hopefully the Wi-Fi gods are with me this time. All right, so can everybody see my screen here?
We can.
Okay, so thank you. So let's talk about the K10 platform. The K10 platform was purpose-built specifically for Kubernetes. It is a Kubernetes backup and mobility made easy solutions. And first things first, K10 is application-centric. It automatically discovers all the applications in your cluster. An application, as Niraj mentioned before, should be the primary unit of your backup and recovery story. And K10 can capture all the application details you need, including not just the data, but also the configuration and other data that you might need to have a complete backup. K10 is also policy driven. Now, every application in the Kubernetes environment can be different, but you cannot write scripts for every application or have one-off backups every time you need them. That is not scalable. A policy-driven automation is much easier and scales better with your cluster. With K10, you can set up policies that could span, say, multiple applications, and you can have a completely automated backup and recovery story. End-to-end encryption is also critical. The backups should be secure, and the encryption should also be handled correctly. Lastly, K10 is super easy to use. It has a simple UX, and the application sits directly in your cluster, so it's very easy to manage. Let's go back to this Kubernetes architecture view that we had from before and see how K10 fits in over here. First up, we have the orchestrator APIs. So K10 can talk directly to the Kubernetes API to discover your applications and all the components of the application that it needs to perform any lifecycle operations. Again, K10 is Kubernetes distribution agnostic, so your Kubernetes platform could be anything. Next up, we have... Yes.
We had a question, right? I think you just answered it, how you discover applications, right? Via the Kubernetes API. But, you know, the second part of the question was, what do you mean by an application in Kubernetes?
Yes. So if we go back to what Niraj had previously, I can go back to the slide, I guess. This, as Niraj has mentioned before, is the entire application. So it's not just the persistent volume that we have here, but everything you need to get this application up and running. So that could be some config maps that you have in your application, or some pods, or maybe sometimes you might have some special service accounts, or even role bindings that you have in this application. So everything that you need for this application to be up and running without having to do any extra steps comprises of your Kubernetes application. I hope that answers your question.
The one other thing I'd add to what Deepika said is generally a default grouping is at a namespace or project level, but it is possible for a user to define the application by including or excluding stuff using labels as an example. So there's a default grouping of components and some cluster resources that also make up the app, but you can get more specific if you really want to.
Yes, thanks, Niraj. All right, back to this. So we spoke about the orchestrator APIs, and next up is the infrastructure APIs. So apart from talking to just the Kubernetes cluster, K10 can also integrate with your physical or virtual environment with minimal integration. So it supports block as well as file storage. And for more complex use cases, like say cross-cluster migration or cross-region restores, it also integrates deeper into that, as well as it has integrations for CSI. Next up is the application layer. So the application framework allows users to create policies that span multiple applications, but sometimes that's not enough. You might be running specific applications that need specific blueprints or hooks. Say you want to run some commands or functions right before you take a backup, or you want to run some transforms on your configs or your specs right after you're done with your backup, but before you want to restore it. So K10 gives you the freedom to choose either a policy-driven application, or you could have specific application blueprints that can be deployed in the cluster. Let's go look at a cluster that we have here that has K10 deployed and see what we were talking about. So here we have a simple Google cluster. As you can see, I have a few namespaces and I have a MySQL app running. Now this is the K10 dashboard. So it's easy to use. It sits right in your cluster, and I can click on the applications tab right here and view all my applications in one place. So like I said, I have a MySQL running. Now in the API, in the Kasten dashboard itself, I can click on the details and I can see that it has one PVC attached. which is an 8 GB PVC, but it also has discovered all the other information that it needs for this application, like networking or config files. Now, for this application, I'm going to create a policy that takes a snapshot for this application. So here, the name of my policy is MySQL backup. I have taken an action snapshot, and I can choose the granularity of the frequency at which this policy runs. So I could choose it hourly or even yearly, but right now I'm going to choose a daily policy. After that, I can select my application here either by name or I can choose by labels. So like Niraj mentioned, you could have applications that are grouped together by a specific label. Say you have a label application 1.0 or application 2.0, and you have multiple applications with that label. You can easily set up a policy that covers all of them together, or you can set up individual policy runs. So here I'm choosing by name a MySQL application, and I can do create policy, and it will create this policy for me. So this is a nice way to show what the policy does. You get the name, you get what the policy is working on. Here it's working on the application MySQL, and it's going to run a backup daily. Now to make this policy run currently, I can click on run once with this little guy here, and it will run this policy immediately. So I'm going to run this policy right now so that it triggers a backup. Let's go back to the dashboard and see if it has triggered. So now that the policy has been triggered, we can see that there's a backup running right here. And this backup is on the application namespace MySQL. Niraj, are there any questions while we wait for this backup? You're on mute.
I was on mute. There are a whole bunch of questions, so let's take some of them.
Yes.
All right. So the first one I think we'll leave to later. There's a question about is K10 multi-tenant? Can Kubernetes users schedule their own backups, etc.? Deepika will actually show this later with demos. So we'll just run through that. So keep that in mind. Deepika, there's another question for you. Do you currently support NFS as a backup target interface or only S3?
We have object store compatible S3, and I believe we have NFS coming up.
Okay. Let's see, what else is next? Does K10 assume CSI provision PVCs, or can any PVC be used to both snapshot and backup?
I think any PVC could be used for snapshot and backup, but we can also do CSI specific stuff if the underlying storage allows us to.
Yeah. So to give more color, right? CSI is great. We support CSI-based snapshots, and then we can extract backups for that. But it's not always the most efficient in its current form. So we often hook into most common storage systems, right? Think about vSphere's API, EBS, etc., to directly extract data from that for efficiency reasons. Yeah? And then finally, I can also take the next question as Deepika gets ready for the next section of the demo. But can K10 backup and restore etcd? Essentially what you're seeing here, we are doing an etcd backup logically. etcd backups are not portable across clusters, but we extract all the application resources from etcd, and we can push that into the an etcd in the same cluster, in a different cluster, things of that nature. It's also possible to directly backup etcd, but we don't recommend that. And the other part is, another question is similar to what I just answered, is does K10 take advantage of backend storage snapshot capabilities available? Yes, and we are even doing further things in that space. Yeah. Yeah. So, all right, Deepika, back to you.
Thank you,
I'll let you go on.
Our backup is complete by the time we answered those questions. So I can click on this backup action directly, and it will open this panel for all the details. So as we can see, it took a Kubernetes volume snapshot right here of the PVC that we mentioned before, as well as it also captured all the other specs like the secrets or the config maps and even role bindings that are in this class, in this specific namespace. So now that we have this backup, let's go back to the application. Now I can see that right here, I can restore this application. So if I click on this, I see that I took a backup today at 9:29 a.m. And now I can use this, which is a restore point, simply a representation of the snapshot that we just took, and I can restore this. Now, there are two ways to restore. One would be to restore it directly in place, which should be like, for example, if you lost some data or say you want to revert to an older version of your system, you can use restore in place. Or you could use to restore in a different namespace, which would be something similar to cloning. Say you want to run multiple instances of MySQL in your cluster. So that's what I'm going to do now, where I'm going to create a MySQL 2 namespace, and I'm going to use this snapshot to restore it in there. And let's just click on restore, and it will trigger a restore for this application. And then we can go back to the dashboard and view what it's doing. So the restore is going to kick in, and that's again going to take some time. So Niraj, any more questions?
Sure, there are a couple. So first of all, it's, are your backups application consistent on Kubernetes?
Yes. That's the short answer. I think Niraj should give the long answer.
So the way I would answer this question is that, right, there are different users and different customers, different applications have different needs. And today what K10 can do is support a full spectrum of consistency options. There's everything from crash consistency, which works in the common case when you want a generic policy. There is what we believe is somewhat misnamed, that is app consistent, that is you quiesce your database and then you go snapshot that. And that is available in an agentless manner. If you remember the diagram Deepika had shown earlier, that in an agentless way, we can define blueprints. So, we have examples for MySQL, Postgres, Mongo, etc., which quiesce the database and do that. Then we have actually some more interesting ways of making application consistent backups. That is, we go look at it from the perspective of doing a logical dump. Say I want to use extra backup, PG dump, and push that into object storage. So that is one scenario that can be used. And then finally, we can do a lot more complicated things in the Kubernetes world, where say I have a replicated MongoDB system. In that particular scenario, maybe just identify the replica, freeze and snapshot that, not impact the primary, but on restore, use that replica copy for all different disk images. So you have multiple restores from the same snapshot. So there are many interesting things you can do. And within the same cluster, different apps can be in different points on that spectrum. So we got those couple of answers taken care of. And Deepika, there's another question. Can you use pre or post hooks before backup restore that are configurable via CRDs?
Yes, you can use pre and post hooks. That's a more detailed, I guess, policy-driven use case. But we have examples on the slides that you can use that.
Yeah. So also to add to what Deepika said, this is, you define your hook as simply a Kubernetes extension. And I think Deepika's going to try to...
Yeah, I'm going to look at...
set that up here.
Yes.
Right, so it's hidden because, but as you can see on screen right now, you can have post-export hooks, you can have pre-hooks, multiple different options that you can add there. Okay. All right, Deepika, back to you.
Yes. So in the meantime, the restore has completed. So again, like we looked at the backup, we can look at the restore application, and you can see that it has restored the volume. We can go back to the kubectl command and look at our namespaces, and we can see that we have a new namespace, MySQL 2, up and running with using the snapshot that we took for the MySQL application. Now let's go back to the slides. And like Niraj mentioned, there are some concerns that you need to watch out for, but there are even more concerns that you need to worry about when you're thinking about stateful applications in Kubernetes. The first step is security and protection gaps. Obviously with Kubernetes, which is architected specifically for fault tolerance, which is great, but with high reliability and availability, it's still not a backup. You have malware and ransomware that get targeted specifically towards Kubernetes, and it is very easy to lose data, as well as have the data corruption replicate super quickly and have catastrophic effects. Kubernetes does have some measures that it used to mitigate that. For example, you have network policies where you can deny access to internal applications as well as untrusted outside services from communicating with your application. Now, how do you define a backup and recovery solution in such a scenario? You cannot have something that is running outside of your cluster. If it cannot access your cluster, it's not a good backup solution. You need something that adheres to these network policies and also You don't need to change your network policies just to accommodate for this data management strategy. You cannot always compromise your security when you're trying to run a backup and recovery story. So you need something that runs within your cluster and helps you manage everything without having to make these changes. And the question that was asked earlier, Kubernetes, yes, allows for multi-tenancy with the use of tokens as well as role-based access control or RBAC. And you can have multiple tenants in the same cluster with different tokens who access different parts of the cluster and are completely isolated from each other. So each tenant has their own sandbox and they don't need to care about the other users. So a backup solution that understands this and also takes advantage of these security features is what's needed right now. Apart from security, we also need to worry about the ecosystem. The Kubernetes ecosystem is integrated with a lot of services and not just databases, but other system hooks and other applications. The ecosystem now, as we've mentioned multiple times, includes everyone, not just the ops or IT, the developers, the storage admins, everyone. A solution that understands this cloud native approach and enhances this ecosystem will be able to harness it and see everything and be able to use everything that it has to offer. So be it integration with Prometheus for monitoring and alerting, or be it integration with the Kubernetes native APIs, like the custom resources or APIs for RBAC and logging and auditing. Apart from all this, the main benefit of Kubernetes is the portability. You do not want to be tied down. You need that freedom of choice when you're selecting your infrastructure, whether it be on-prem or in the cloud, and you should be able to use whatever storage system you want without having to worry about what your data management strategy is going to look like. The solution that you have for your data management should not have deep hooks in your storage or your infrastructure, such that you can't migrate or you can't move to a different storage system. You need a system that will allow you to constantly move, migrate, and switch, which is the biggest power of Kubernetes. Now let's go back to the demo and see what else we can do with K10. And Niraj, do we have any questions in the meantime?
Yeah, Deepika, before we jump back into some of these demos, right, there were a few follow-up questions from your previous demo.
Okay, yes.
Right. One of them is somewhat translating here. The demo you showed previously has backup and restore of MySQL that was not using native tools, so the storage or volume level.
Yes.
Would it be possible to run into data integrity issues there?
Sorry, can you take this one?
Sure. So happy to take this one for Deepika. In short, in particular for MySQL, it has seen production use. It tends to be crash consistent, and that's fine. But in the same system, it is possible to also quiesce, as we talked about, take the app consistent backup. And for whoever asked this question, if we have time towards the end, I can bring up one of my personal test clusters where I'm running 3 or 4 versions of Mongo, right? Crash consistent, app consistent, logical data dump. So all of that is possible. So it really depends on what the customer wants to implement for these applications. So that's the one thing to think about there, all right? And then there was another question. Today, does K10 need to be installed on every Kubernetes cluster?
Yes, it runs a single instance in every cluster that you have. Sorry, did I lose you there?
Yeah, the other thing I would add to Deepika's question is it is possible, right, to alert, monitor, log in a central place. So when you're multi-cluster, we do a lot of things to make life easier for the operator of these platforms. But at any, if a single cluster, we do need to be within the cluster because of what Deepika just mentioned in the last couple of slides, where when you have applications that are sandbox, when you have applications that have network policies, like for example, your MongoDB is not visible even to other applications in the same Kubernetes cluster, you need something within the cluster to be able to do backup, because otherwise you're weakening core security properties. And not only will you run into issues with your InfoSec groups if you do things like that, but it just weakens the nature of the reasons why you've picked this platform. So that's why we hook into things from the API layer within the cluster versus external to the cluster. Yeah. And there's another question about having K10 and Istio in place for network segmentation. Are there any issues? No, people run us with other service meshes, Linkerd, Istio. Generally, most of these things are transparent. And we have ways how you can expose us via different routes, ingress, etc. So we plug into the broader ecosystem well there. All right. Deepika, I think that takes care of most of the things. The outstanding question now was, hey, is K10 multi-tenant? Can I leave
Yes.
Kubernetes users to schedule their own backups, etc.?
Yes. So let's get to that question first. So as you can see in this cluster, I am logged in as the K10 admin. The permissions are unrestricted. This admin can view all the applications, can view all the restore and backup actions for this cluster as a whole, irrespective of the applications. But since Kubernetes supports multi-tenancy, you could have users that you do not want to give them this access where they can see everything. For that, we do support token-based and role-based access control. So here I'm logged into the same cluster, but here I am with the MySQL admin. So this user has access only to the MySQL namespace and has limited permissions. So again, this user can see only the applications and the actions that are in their specific namespace. Say we have a third application, say MongoDB, we could have another user that has access only to those applications, and they'll have a limited view of the same dashboard. So the way Kubernetes fragments it in the kubectl with namespaces, the same way you can do it in the dashboard with these users. So we do take care of multi-tenancy on that aspect. The second thing that's most important is the integration with the Kubernetes API. So let's go back to the policy, and you can see that there are these tiny breadcrumbs on the website. So I'm going to copy this kubectl command, and I can paste it in the terminal, pipe it to an output YAML, and I can see that the policy directly in the kubectl command line. And same thing, I can see the YAML on the UI as well. So this is due to the amazing custom resources that Kubernetes offers to extend its API. So everything on the dashboard that you see, including all these actions, are all Kubernetes API based. So if you hate this UI and you love your YAMLs and are very happy with kubectl, you don't need to learn anything new for K10. You can do the same backup and restore triggered directly from the kubectl API, and you don't have to use this dashboard ever again. So hopefully that helps understand how K10 integrates with Kubernetes. As I've mentioned before, it is purpose-built for Kubernetes. It is leveraging everything that Kubernetes has to offer. And with extensions to Kubernetes API, like custom resources as well as aggregated APIs, K10 manages everything directly from your cluster without you having to worry about a new data management strategy, something outside your cluster, learning new APIs or learning new REST-based stuff. It's not required when you're using K10. That's it from the demo side. Niraj, any questions that we have here?
So let's say a couple of other questions, one comment in the chat that I do want to address. But yeah, if people have additional questions, right, we can always do more demos. So really, this is free form at this point in time. So ask questions where we can show more things if you're interested. If people want to see multiple consistency levels for apps, happy to bring that up if there's a request, right? So just let us know. But I love it when we have also our users on the webinar. Someone brought up that, hey, you really haven't spoken about K10 for DR or cloning environments, because that's what they've done in Oracle Container Engine for Kubernetes. And right, the purpose of this webinar was to focus on some of the initial use cases on backup restore, but that is completely correct. People use us for migrating from on-prem to public cloud and vice versa, right? For DR reasons. Recently, we also did a webinar with Red Hat and our customer. Well, 90% was a customer talking Supersteria, where they showed how they went across 5 Kubernetes upgrades and 5 OpenShift upgrades and migrated across clusters, across storage systems. So that's somewhat different take on disaster recovery. But whether you talk about cross availability zone, cross region, cross data center, hybrid environments, but the fact that there's now this common API you're deploying your applications against also allows us to support you moving applications across all these CNCF certified Kubernetes distributions. So if you have questions on that, we can also talk about some of those things. Okay. There's another question. Any plans to integrate with the Kind project for backup restore testing? Maybe. This is from another user, and what I will say is I think this user has been spying on us, because in the release that comes out tomorrow, we're going to have documentation on how to easily install us in Kind. You copy paste one piece of text and you can bring K10 up on your laptop, take snapshots, take backups, use this with Minio. So you can evaluate K10 on your cluster, on your laptop, right? We scale according to load on the cluster, so it's not this big honking thing. So it should just be very easy to get this up and running if you can't get up and running on Kind in 15 minutes or less, please complain personally to me, okay? But it should be very easy to get set up. All right.
You can always try a forever free starter edition on the website. And as mentioned before, Kubernetes is backup, and K10 is Kubernetes backup and mobility made easy. And K10 is truly Kubernetes native with all the API and all the support that we have. You can always, like Niraj said, with the Kind cluster, very easy to just set it up on your laptop and you can go and play around with it.
All right. Any other questions right now? Okay. If not, you can always find us on Twitter, right, at Kasten HQ. You send us email. There's a website chat functionality. Go try us out. I think if you're deploying stateful applications, the amount of value we can deliver will be great, given just how so many things have changed in the Kubernetes environment. And this is not just technology, it's also about culture. It's about the stack surrounding it, CI/CD pipelines. How does backup restore? How does DR? How does app mobility work in a multi-cloud world, in a multi-tenant world? Is something we're very squarely focused on. So if there's anything that we can do to help, please let us know. Please, feel free to reach out to us personally or the company, whatever you prefer. So unless there's anything else, any parting questions, I want to thank everyone for the time. We will post slides and recordings online in the next couple of days. Video will be on YouTube. You're not getting this content, and we'll send email out in case you want to go have a look at this in your spare time if you want to review any material. But the other thing I'd also point out is if you go to kasten.io/resources, the previous customer webinars on there are customer case studies, and I think you might also benefit from looking at that. So thanks, everyone. Really appreciate your time today.